And one of the things that we kind of strongly have as a principle to differentiate at Bellatrix is that we only build innovative products. If a product is not innovative and not competing with some of the global companies out there, Bellatrix will not take up such a product.
Hey folks, welcome to First Cheque Portfolio Shorts. My name is Noah Martins, and this is the series where we speak to founders of our portfolio companies so that you get to know their team, understand what they're building, and the problems they are trying to solve. If you like the content that we've been putting out, do like, share, and subscribe so that we can reach more founders and startup enthusiasts like you. Today's very special guest is Yashas, co-founder of Bellatrix Aerospace. Bellatrix is an Indian new space company specializing in in-space propulsion systems and orbital launch vehicles. Based out of the Indian Institute of Science, Bangalore, the company is constantly evolving to facilitate the development of key technologies in electric propulsion, new generation propellants, and launch vehicles. I had an awesome conversation with Yashas, and it is genuinely mind-blowing to listen to someone who's trying to solve the kind of problem he is. So do stick around till the end of the episode. Yashas, thank you so much for joining me. It is an honor to host you.
Thanks for the invitation. I mean, always a pleasure to talk to you more.
All right. So let's start by talking about the problem that you're trying to solve.
At Bellatrix, we are actually building next generation engines for satellites. So we started looking at what is there in the market in the satellite industry. Basically, I'm talking about engines that are going to help satellites move in space. Like we have Fiat engines on our Hyundai cars and maybe on a lot of cars out there. Like that, we want to be the Fiat of the space industry, where we want our satellite engines to fly on most of the satellites that are going out there globally. And we looked at what are the kind of technology that are out there in the market currently. So one of the things that we saw was that the technologies that current satellites are using were built several decades ago. So these are kind of old and obsolete technologies, and there are a lot of innovations that have happened a lot on the academic sector and few in terms of space agencies, the government agencies which have been working on a lot of innovation that could actually push the boundaries of where the current market products are in terms of maybe the performance that an engine can deliver, or in terms of the fuel efficiency that these engines can deliver to the satellites, which in turn kind of increases the return on investment for the satellite manufacturer, which finally percolates to the end user. So if we are paying for satellite data or some other kind of satellite services, satellite images and all that, the cost of all that comes down from the cost of infrastructure that we built, right? So effectively, we want to get down that cost that could percolate towards the end users in terms of making space more affordable. That is how we started Bellatrix. And one of the things that we kind of strongly have as a principle to differentiate at Bellatrix is that we only build innovative products. If a product is not innovative and not competing with some of the global companies out there, Bellatrix will not take up such a product. So that is where we are looking at.
Crazy. Okay, so tell me a little bit about your progress so far and about the hardware that you are working on at the moment.
Yeah. So when we started out, right, we started out with one product which is called the microwave plasma thruster, which is like one of a kind propulsion system which uses water as fuel. Rocket's job is to take a satellite from ground and then take it to an altitude of like 400, 500, 600 kilometers and drop it off, and the satellite falls back to the Earth. That is where our engines help satellites maintain their correct orientation in space. And then if they have to go from one orbit to higher orbit or lower orbit, or change their inclination, the way the antennas are pointing or the way solar panels are facing the sun. So these kinds of changes are done with the help of our engines. That's where we come. Then a new technology called electric propulsion came in. It is like the electric vehicles in terms of fuel efficiency or the cost savings that we get here. Something very similar came in the space industry, which uses a fuel called xenon. Xenon is a gas you would definitely be aware, but we use very, very high purity xenon, which is extremely costly. So we thought that to reduce the cost of access to space, we need to kind of look at a fuel that is, abundantly available, very cost effective, very simple, non-risky, That is where we decided water is one such fuel which kind of comes in there. So we built an engine which uses water as fuel, and we have currently got patent in US, Europe, Japan, and all these places. It's the first engine that any company worldwide built using water as fuel for these kinds of applications. And that was the first product. And soon after we got that, we got into a contract with ISRO. And eventually we also decided to diversify. We started talking to a lot of potential customers. We were talking to the Boeings, Airbus, and these kinds of companies and trying to understand their requirement. We realized that we can't be a one product company.
Right.
So we decided to like diversify and work on four completely different technologies in one startup, which are four hardware technologies to be very specific, which could help us cater to any and every kind of a satellite mission. Even if you want to probably send a probe to Pluto, one of our engines would fit into that. Right. And you want to send a satellite to as low as like 250, 300 kilometers into space, we have a solution for that. The smallest satellite, the heaviest satellite. So now we started working on these kinds of technologies. Now we were thinking, Fiat also makes engines. Fiat also builds their own car. So why don't we build our own car? Which means like we started to build something called space taxi, which is like a logistic solution where you take multiple satellites on a mothership kind of a satellite, go to one orbit where the main rocket is going, and from there, our space taxi is going to do the last mile delivery, where we are going to go to all the different orbits that these satellites have to go, launch them there. Essentially, what we are trying to solve is we are trying to make rocket rides more affordable using the space taxi. It is like if you want to go from Bangalore to Hyderabad, you book a taxi from Bangalore to Hyderabad, it's going to be very, very expensive. Or it's like taking a chartered flight, right?
That's awesome. All right. Talk to me a little bit about how you and Rohan met and why people should want to come and work with you.
Interesting question. Basically, me and Rohan were family friends. We happened to meet in a family get together, and just Rohan was discussing about this interesting project, and I was still like 2 years junior to him. I was pretty excited. So he and two other colleagues of ours, as I was saying, Sagar and Vivek, who are currently with the team. So they were working on this exciting project, and I was interested, and I just joined as a technical member there. But eventually, as we were evolving and things were happening very nicely there, we were able to get something done at college, and we realized that we are sitting on a potential to build a company and build this kind of solution to the entire world, right? Why don't we start supplying these systems to some of the largest satellite companies worldwide? And we clearly had the potential, because with pittance, without any money, we were able to do our first product. And this is not a space, and this is a space where I think any company working in that space has spent like a couple of 100 crores to get to that kind of a stage. So we want to kind of have a place where we want to invite scientists and like people who are extremely passionate to build technology. Right? We want to give them a free hand, let them come in, let them take ownership of the project and try to build on top of that, innovate. So we really strongly believe in innovate. We want to innovate better than every other company in the space that we are operating. So we want to give that free hand. And in terms of culture, we believe in ownership. We want our people to take ownership, and they own. It's like we want the project to be their baby. They want to conceptualize and they want to work on it, build on top of that. So that is the kind of workplace that we kind of have. And in terms of the kind of people that we have, so we have a mix of all sorts of people. So you start from freshers, we have freshers, and then we have people who have worked in the industry for more than 10 years. And then we have retired ISRO scientists who are helping and advising us, or some professors from IISc or IITs who are working on specific areas of our projects. And in terms of the kind of areas or streams that we recruit or we look at, we are almost multidisciplinary, right? Starting from mechanical engineering to aerospace engineering, and then if you're doing chemistry, if you have done PhD in chemistry, we build propellants, so you can come and work in that. And then you're doing plasma physics, we work on electric propulsion, where we deal with plasmas that are twice as hot as sun's surface temperature. So you need to control those. So we kind of also have highly talented plasma engineers working with us. And then basically we are a space company, right? If you have worked on space systems engineering or building satellites, or if you're working on structures, elastomers, polymers, tanks. So we kind of have a mix of all these kinds of people. And one new addition that has come up is also software engineering. So if there are some people who are very good in software but want to break out of the MNC industry or break out of the software industry and get involved in some pure problem solving for hardware, right? These are like embedded kind of challenges. You want a spacecraft to maneuver in a particular way in space, and you don't have a lot of data sets. So a lot of AI ML kind of jobs also come in here. So if somebody is interested to come out of the software industry and really follow their passion, build something great for space, then we also have space for that.
Thank you so much, Yashas, for taking the time. It is genuinely cool to see what you're building.
Oh, great. Thanks.